Hey folks, George Leoniak. I'm coming in with another video. This week I've been pretty excited about the golden spiral, golden rectangle. On my Facebook account I posted a image, this one here, and I'm going to show you today how to construct this. Came up with a pretty nifty way to create the golden rectangle, which I don't believe I've seen anywhere else. I haven't seen it anywhere else. I'm probably out there, but this one really got me a very simple method to do this, and I'm looking forward to sharing that with you here. If you're new to my drawing videos, there's a couple things you'll need. I like this straight edge. I know some people prefer a metal edge, but I really like this one, and I've talked about it in the past because it has the divisions of the 1 inch square, so it's 2 inches wide along this. This is really going to help you out a little later on, just to line up the edges when you're doing that rectangle to make it nice and square edges. So I use this quite a bit just to make sure I get nice edges. The other thing here, a good compass that's locking in place. So, the ones we had when we were kids in school, maybe some of us had, that were just always the radius was changing, and probably made many of us dislike geometry because of that, amongst other things. But when you get a good compass and the straight edge, you're all set. A good mechanical pencil, or a mechanical pencil, or a pencil, anything to write with, draw. And I also think at some point down the line, as you get more into this, investing in some phi calipers. I like to, on a drawing like this, put the phi calipers up to it, or other drawings that I'll do, and it'd be like, is that even close to a phi relationship? And you can just expand these out to show where the phi relationships are at the various different intersections with the lines that we're drawing on here. So definitely they're a little pricey, but well worth the investment. You'll start measuring all sorts of things between the eyes and one eye and the other, framing my eye and the other eye there. That's a neat one. So, it's cool because the golden ratio is found in many things all around us. So like I normally do here, I'm going to share the screen. I've got the presentation set up here to walk through those steps. Have an opening slide here that is just going to kind of give us a bit of an overview of what we're going to be drawing and what we've done in the past on some of my other videos that you might look forward to checking out after this one. In the silver spiral video, I talk about the metallic means in that. And of course, the golden spiral is one of the metallic means. It's the one that's based on 1. And the equation that we're using for this, and you don't have to get lost in all these mathematics, but essentially all the numbers down here is just adding a 1, a 2, or 3. And then this is 1 plus the square root of 5. Will give you, divided by 2, gives you the golden ratio, where 2 plus the square root of 8 plus 2, divided by 2, excuse me, will give you the silver mean ratio here. So, the golden rectangle and golden spiral is one of the metallic means here, but it's not the only one. And the silver spiral can be constructed like this. But the beautiful thing about the golden rectangle, or one of the most interesting things that geometers have explored the depths of, and it continues to bring them further into this mysterious process of the as above so below statement. And phi, the numeric value, or even without the numerics, just dividing the line on that point, this will always be true. So when someone says something's in phi relationship, the best way to look at that is just summing it up the whole, and we can look at this, visually here, and that's why these visuals help. The whole is this a plus b, 1.618, is to the greater, which is a, which is the 1, as the greater, which is the 1, is to the lesser, which is the 0.618. So what that means basically, if I divide 1.618 by 1, well then I'm going to get 1.618. But now if I take 1 and divide it by 0.618, then I will also get 1.618. So then if I divide 0.618, this edge, because this is a smaller little golden rectangle here, because that's essentially what the golden rectangle is. Each of these are successively smaller golden rectangles. So if I divide this edge, 0.618, divided by 0.381, when I plug those numbers into my calculator, I'll get 1.618, which is phi. So any place that you divide this line, it's going to divide it into two numbers, whatever those numbers are, that when you divide them, the larger by the smaller, then you'll always come up with 1.618. So A plus B is to A as A is to B. So yeah, it's just, the other thing is if you just plug in, of course, these numbers with the 618 ... or 0.381 ... if you just put 0.381 and divide that by the 6.18 divided by the 381, then you're going to come close to a number. So you have to use your calculator in a way that you're using the whole string of digits, or else you'll get numbers that aren't exact. So that's something I learned through trial and error, is that there's no more just typing in 1.618 and that's phi. You have to actually do the equation to get the whole string of digits, which go much further than what your calculator is showing you, but the calculator itself is storing the rest of those digits, so all your other calculations will be correct. Just a minor aside, if you get into working with these numbers, you can't just cut off the numbers. You have to use the whole sequence of numbers, which the calculator only shows some, but the rest are there. So, okay, so let me just describe the Fibonacci spiral and the Fibonacci sequence a bit, because that's usually in relationship to the golden rectangle and the golden spiral. So here are the numbers, and this is neat to see because I didn't realize this till I put this together, is that if we base both of these on a 1-inch square, normally we go 1 plus 1 to 2, so the Fibonacci sequence is starting at 1, but here it's actually going in the reverse order, which means that, this large square is to this square, which is the 0.6 to 0.4. So the smallest little squares, that should be slightly smaller, the smallest little squares, the 0.2 squares here, are where you're starting. 0.2 squares plus each other is 4. 2 plus 4 is 0.6, and the 0.6 plus the 0.4 is the 1, of course. So that gives you a little spiral here that's 1.6, but of course it's not the 1.618 magic number that phi gives us, because these are not golden rectangles, because it's starting with 2 squares. So now we have, if we compare these two spirals, I've got one underneath here that I can move up there. We could place that over top, and it's going to be fairly accurate. It's not going to be. Let's see if we get really close in there. We've got the slight little, especially in the beginning, it's going to be way out of the phi proportion here. But as time goes on with the Fibonacci sequence, what happens is that those numbers, when you divide the greater to the lesser, it's going to show up as the phi relationship. So, okay, well, I've got a phone call coming in, but they're going to have to wait. It's a double call, but I think we should be all good with just continuing on here. So let's see here. We've got, the next thing we've got is, if you're going to do this drawing, so I'm going to show you how to do the golden rectangle. The majority of the other videos that I've shown you, I often am just showing you the whole circles in the drawing. So we've got these two giant circles. We've got the 2-inch, actually the 2.828 inch circles, the root 8 circles. So we're going to actually, instead of doing the giant circles like this, we're just going to pretend that the circles aren't there. We're just going to do these little hash marks when I show you the construction here. But I just want you to know that these are going to be, they're part of these circles, these full circles. They're just these little slash marks. So that's just an aside. Now, if you want to draw this specifically to get phi, the 1.618 measurement, that means that you're going to have to base your initial drawing on, let me zoom in a little bit more now. You're going to have to base your initial drawing on a measurement that's an irrational number, 1.414. You don't have to do that. This, for instance, the drawing that I did, I just drew a line on here and just started with the method I'm going to show you. But if you want to get this to be accurate to phi, so you have the 1 and the 0.618 on the other side to get the golden rectangle, then you need to start out with this 1.414 line, at least the way I'm constructing it here. Now, the way you can get that line is just quickly on the side of your piece of paper is just do a 2-inch, 1-inch diameter vesica Pisces, do your 1-inch circle in the middle, and then go around and do all the other circles. I've done this in a lot of my other videos. If you're going to do this anyway, I'm assuming you know this method. And then when you divide the root 2 measurement, you'll get the root 2 measurement, which is 1.414. That's root 2. That is going to, just set your compass from here to here, and now create that edge length to start with. So, you'll be able to drop that 1-inch square. This is a 1-inch square right in there. You don't really want to draw this right over top with all these other lines to get that edge, because it just, you have to start off doing the vesica Pisces at a 45-degree angle, etc. So anyway, this is just how you can get that edge really simply without having to guesstimate, because any 1-inch cube or any 1-inch square has got a diagonal across its face that's going to equal this 1.414 irrational number that continues on and on and on. So anyway, like I said, you can just draw a line on your piece of paper and we're good to go. So now that we have that length, what we're going to do, the 1.414, or whatever length you're going to use, we're going to, do our vesica Pisces, which is going to be, these could be complete circles, but remember, just set your compass here, bring it over to this far end, and just swing it around. So the diameter is twice this distance of the radius. And after, constructing my first drawing here, because now you're going to draw a line, this is how you're going to get quadrants out of your circle. You draw your line straight down through the middle, and I just happen to think, wow, what a great way to start off the design with creating the phi symbol, the circle and the line. So because both of these measurements are actually going to be critical, especially this one, and this is what makes this design rather unique in the way that I am constructing it here that I've seen. So next step, we're going to draw that circle. We're going to set our compass radius again. Now here it will just be at the 1.4 or half of 1.414 or whatever your distance is. And we'll draw that circle. And now we set our compass to this point. Don't change the radius. Put that to the center where the lead is. Do an arc here and here, and then set it here. Do an arc here and here. Set it here. Do an arc here and here. Set it here, and do your arc. So all we did there, and of course I've done this a bunch of times in the other videos. Hopefully you've seen some of those. If you haven't, hopefully that made sense. So you draw these arcs, because all we did is we just divided this into eighths, because we want to set up our square, which is going to be on the inside of that. We don't need to draw the square. Really, all we needed to do, we are going to draw the inner square soon, but we needed to do that so at least we could draw these lines in. Next step is you can set your compass again. And now we're going to set it up at the top of the Vesica Pisces, the one that you started with right here. And we're going to draw that. Now, if you're doing the measurements of the 1.414, then this is going to give you root 6 as the measurement. Typically, this is root 3 when we do the other diagram of just like a 2-inch diameter circle, but here it happens to be root 6. And I find that root 6, at least in the sacred geometry literature, doesn't get a lot of press. It's not typed up a lot. I don't see it in a lot of calculations, but I found root 6 to be quite useful in a lot of applications, especially as it relates to the flower of life design and the size of the spheres. 1.5 divided by, root 6 divided by 1.5 gives us a sphere within the flower of life that I like to use a lot. But anyway, so we've got this root 6, and now we've got our root 4, 1.4, root 2 circle, sorry. And now from there, we have a simple construction, and all we have to do is draw our 1-inch square within. Now it's going to be framed in this circle. And this is the cool part about this. This is the part that I was really excited about, that I haven't seen constructed like this anywhere else. All you have to do, and you can do this with any 2 circles that are in this relationship, you just draw a line all the way across until it hits that root 6 circle, and same on the bottom. And when you connect these lines, you've just divided the 1-inch square by 0.618. So you've just created a 1.618 length, or whatever your length is. You've created a golden rectangle right here. Now, the part that I was really contemplating a lot and was super excited about, or was really intrigued by too, was that when I draw in, this is a common way to find where the center, where's the origin of that circle, where's the origin of the spiral, excuse me. So the origin of the spiral, get that out of there, it's a little too big for showing you where it is. So the origin of the spiral, when you draw this red line from corner to corner, and you're basically doing it on the other golden rectangle. So this is the diagonal of the golden rectangle, and this is also a golden rectangle, remember. You're doing that diagonal, and where those two meet, that is where the center of the spiral originates from. So it is right on the circumference of this circle around the square, which is just fascinating. And these outer ones touch this outer circumference of the larger circle. So right here at this location, the point of the point of the spiral is on this transcendental circle circumference, which is related to pi. The circumference of a circle is related to pi, the 3.14. So really, really interesting coincidence. Synchronicity, whatever you would like to call it, is really fascinating that that would land there. And I checked it out in a much more accurate, precise drawing tool that showed me that that is precisely on that line without any discrepancy. PowerPoint here and doing these presentations can get a little iffy, and in terms of checking things out just by eye, or even your hand drawn. There's so many times that I've done a hand drawn, I'm like, wow, there's phi ratio or whatever. And then I go and do the math to find out, actually, the lines were just in my favor of looking like that, but the actual reality of it is that it's not. But this software, the other software that I'm using on an app, just shows me perfectly that that is true. So now the neat thing here was just another little root that shows up. The square root of 5, of course, now this is how traditionally geometers will divide the line is you'll do your 1-inch square here. You'll go up to this section here and you'll draw an arc that will meet and touch down at this line. So that will give you root 5, 2.236. And of course, that's the number, the root 5, that relates to the phi ratio. So this will also give you root 5 within relationship to the root 6 circle and the root 2 circle here that we have. Just an amazing amount of sacred mathematics that are going into this diagram. I think that the new thing about this is how this root 6 circle is integrating into giving you those outer points. All right, so how do we construct the spiral? Here's the steps to do that. Now, you're going to set your compass. So you should have that all set up by this point. You'll set your compass to the 1-inch edge here and just set it over here. So it's a 1-inch, half a quarter of an arc here that's going to go up to this spot here. So now this is not really the way a true golden spiral would be created. It's not created out of these quarter arcs that I'm going to show you here, but because it has an ever expanding radius that isn't just chunks, you know, it's not a solid line that has a consistent radius along here of 1 inch and then another radius that's, you know, the next 0.618 radius. So, or whatever that would be there. So, you know, yeah, that would be the 0.618 radius. This would just be a continually expanding arc, but it would hit these nodes as we go. So this is the best that we can do with our compass to create this design. So the next step is you're going to really want to pay attention to when you're doing this, because this is where you can definitely lose some accuracy in how these arcs are going to lay out. And don't be surprised if you're doing it that things are just slightly off there. But you want to focus on, so here's your needle of the compass. You're going to always plant, let's just move that out of the way. Plant your compass needle at this intersection, and you're going to measure up over to here, and then swing your compass down here. Now, you should already have that. First, you have to construct the square. So first, you're going to plant your compass there, come up over to this section, and then swing that compass now back up over to this section. That will give you these points over here. So you're going to create the square and then put the arc within it. But basically what I'm trying to say here is that it's framed in with this node point here and the upper one here. So those are the segments that you want to draw. Now, if you're using that see-through ruler to draw the square, it's quite easy to do because you're just going to set up on your line there and draw just a parallel line to the top edge straight across there. So just create parallel line there and you're good. Next step is we're going to go, and once again, this is where you'll set the compass for the arc. Now you have to create that parallel line as well. So you want to create the parallel line there from here to here. So, you know, set it up so you can get that line going across and then swing your arc there. So we're going to be repeating the same process the next few steps until you just really can't go any further. Same thing, compass needle will go here. It's going to be at that intersection, and then you're going to swing the arc of your compass over here. We can go a little smaller, stepping into here. Needle will be here at this intersection. It's going to swing up over this way. And you're just going to be, you know, part of this sacred geometry is the contemplation of what it is you're doing. You have to, you know, think about and look and analyze and really meditate upon what it is that you're engaging with here, and find these intersection sections, you know, find the intersections and just focus your attention on what's unfolding here is this golden spiral that you're making. And then here's the last one. So all those little node points, when you're all done, you're going to see that they all intersect these segments of just these two lines that go from corner to corner here will actually be going through all the golden rectangles and all the, at the different sizes, all those golden rectangles, the smaller ones, are going to have these same red lines going through them at the different scales. So when you're all done, you should have something that looks kind of like this. And there you'll have that center of the spiral, which you can just kind of cap off. I mean, at some point you won't be able to go any further in there, but now you're going to have your spiral that goes around, emanating from the point of the, along the circumference of this circle, and then expands all the way back down to touch this corner of the first circle that you started with. And if you could erase some of those hash mark lines that you're putting in there. And that's what you'll have when you kind of, I know it's a little off here. I don't know if I can get it lined up just right, but that's what you'll kind of have when you're all done with it. It should look like something like this. And then you have created what I showed you in the first design here. So there's your golden rectangle, golden spiral. Now it's not too far off from getting a little more creative with this design if you choose to. It will just take a little bit more effort and work, but you can create some awesome, designs that are going to have the 4 golden spirals, 4 emanation spots on the outside of the circle here. And they're going to go and meet at the inner corners here. So pretty neat design you can do here. And if, I can't imagine anybody will take this on, but this now is this design, rotated, flipped over top of itself, and then another one. So it's got 16 spirals in here. And then I rotated the whole thing 22.5 degrees to create this octagon type of shape here in the middle. And it's got all the red crisscross lines and spiral lines and the golden rectangles all around it. So, have fun with it when you get to the basic drawing down. And I'm glad I could share this video with you. And I hope that the instructions were pretty clear. And in the end, you'll have something that you can really contemplate and see what insights. I'm looking forward to hearing the insights that you might have as you construct this. I know that I've had quite a few. There's just something very intriguing about the center of this spiral going along with the circumference of this circle. So, share your insights and thoughts, and just let me know if this method worked out for you well. And yeah, I'm thankful for this time with you and looking forward to the next video that I get to share with you. So have a great day and much love, and have a great time with the golden spiral and rectangle.